Welcome to our second webinar focused on media and entertainment for 2021. I am joined today by Thierry Delprat, CTO of Nuxeo, and Lisa McIntyre, Product Manager at Nuxeo. And yours truly, Signar Baez, Principal Architect at MongoDB, and I work closely with our largest media, entertainment, and gaming customers. And as always, please feel free to ask questions by entering them in the Q&A box in the On24 platform. And we also have some time for Q&A towards the end. So today, we will go over digital asset management and content management and how media and entertainment companies have leveraged platforms like Nuxeo and MongoDB Atlas to adapt and respond to the impact caused by last year's major world event. Thierry will then lift the curtains a bit and tell us about how the Nuxeo platform is built for scale and a recent benchmark that was done where over 11 billion assets were handled through the Nuxeo platform. And then we'll finish up with details on use cases at major media and entertainment companies. So without further ado, let's talk about what's going on in M&E. So Lisa, needless to say, the major event last year that impacted everyone in the world has caused shuttering or slowing down of traditional media creation activities, such as photo or video shoots. So how are companies keeping up with the demand for new content?
Sig, that's a great question, because without a doubt, the events of 2020 have really had a large impact on the delivery of and being able to deliver on content demand. With photo shoots and video shoots canceled, the creative staff is suddenly dispersed across the globe. It's been really difficult to create brand new content to drive the customer experience. And yet, what we see is when challenges arise, that's really when creative folks are often at their best. And we've already seen some really good examples of companies using their existing archive content in new ways, probably that they never thought they would need to do. And so they're using this existing content to produce effective, new on-brand experiences. And what we find is that the key to being able to use existing content like this is to ensure that you have the right metadata attached so that the assets can actually be found and then used. And when used in the correct context and in front of the correct audience. So the use of technology like artificial intelligence and machine learning has really started to have a significant impact on how we allow these existing content archives to be cataloged and tagged at scale with not only speed, but accuracy. There's a saying within the digital asset management world that if you have garbage in, you get garbage out. And certainly if you don't have the right information associated with your files, you're doing no good. And so we need to be able to get the accurate content at speed as well. And so to do that, we need tools, right? So within Nuxeo, we have a tool that we call Insight, which uses artificial intelligence and machine learning to actually mine the existing assets that are there. And this becomes really important and relevant. Case in point, if we look at this slide here, we see that it is both the Houston Oilers, which was an NFL team back in the 80s and 90s, moved to Tennessee and became the Titans. Well, let's say the Titans want to actually access some of this older content. I would bet you that many of the people who had any of the tribal knowledge around the Oilers existing as a team are no longer with the company. And so we need to use the machine learning and artificial intelligence in tandem to be able to get that rich, accurate content and metadata associated with the files. Another example of somebody that we've seen using this archival content really well is with one of our clients, Nike. And at the beginning of the pandemic and lockdowns, they were able to relatively quickly generate a video commercial related to their existing historical content, simply because they had access to it in a centralized location, and it was well documented and with useful information.
Outstanding. That's amazing. So again, continuing on the slowing down of the media creation activities, I'm sure there's also kind of an increase in licensing and rights management, obviously to keep revenue flowing, right, for the media companies. So I'm sure this must have occurred, and I think we know that licensing approval, reviews, expediting, and so on is definitely a very elaborate workflow. So I'm wondering, like, how are studios able to handle such workflows now that everybody is remote, for the near future still, and we're well into the thousands of staff and employees, and possibly into the millions in terms of assets that can be licensed.
Right. So it's a good point that ultimately not only is it about the content, it's about how we can use it, and it's also about integrations. Gone are the days where you could take a piece of paper to the person next to you to be able to do your process or workflow. And now what we rely on are integrations with other systems within the organization. Case in point, we have a large consumer product company who they license intellectual property and are a major contributor to that enterprise's revenue stream. So within this company, the licensed intellectual property generated over $6 billion in retail sales from merchandising alone. And they had an aggressive plan for new initiatives coming online to actually make that number grow. And so their external retail partners were requiring these companies to provide ways for the platforms to integrate with the original license holder systems to retrieve the relevant metadata and artwork related to that intellectual property. And so what we're seeing is that many intellectual property-driven companies are looking to develop next-generation digital asset management and distribution platforms with developer-friendly, reliable, and highly secure set of services hosted in the cloud. And so for our consumer products licensing requirement, the solution was to deploy the Nuxeo platform in the cloud as a digital asset management system so that we could search across 350,000 assets so that we could harvest and license that digital content within the creative process. Yeah, 350,000 assets. That's huge. Talk about scale.
Yeah.
And so what they did is they took that creative process, the approval process, to request the new marketing asset. It started within the Nuxeo platform, and it was managed by 2 librarians. Once the request was submitted and approved, the integration was with a work and project management tool to generate the new creative project, and was managed via an integration within their existing Workfront tool. And that tool was open to 2,500 users across the licensor network. And so once that project is completed, the final brand's materials are sent back to the Nuxeo platform through the REST API, where they are linked to the original request, enriched with the corporate master data and licensing information, and then published downstream for that distribution. So all of this workflow from request to distribution has happened within a couple of different systems, but all digitally, all online.
That's amazing. I'm definitely one of the consumers of those licensed products. If you saw my camera the other way, you would see my desk is all full of action figures. So
we thank you for your business, for sure. So now let's get a little bit into rights management, because it's very closely tied into the intellectual property. So as serving digital content exploded, so has that need for digital rights management. Sid, can you tell us more about the complexity of these systems and what are M&E companies doing to keep up?
Certainly. So digital rights management, right, or DRM as commonly known, is sort of a systematic answer to the change in how media products are now distributed and purchased, right? I mean, for the most part, we no longer purchase a physical form, although some still do. Like me, I'm a sort of like 4K video file, right? There is a difference when you see a 4K movie streaming or a 4K movie on disc, by the way. But rather, most of us also purchase a right to access, right? And this right to access goes beyond the end consumer. It extends to like digital billboards, like the picture you see here, in Times Square. That you may see in a public station stop, Times Square in New York City. I miss New York, by the way. I really do. I can't wait to go back. Or maybe as an ad, in our smart TV or a streaming device. So now, let's take this concept of that digital asset and that right to access and think about the many ways access needs to be granted. So let's use a digital movie poster and think of attributes such as width and height, maybe in pixels or maybe in actual physical measures. Now let's add resolution. Maybe it's 1080p, maybe it's 4K, or perhaps a much lower resolution because perhaps it's going to be displayed in an in-flight entertainment system, right? And now let's add locale and its various translations. And now let's add the times at which it can be displayed, Monday through Friday from 8 to 12 p.m. Or, and we could even add like geospatial constraints. Perhaps a digital movie poster can only be displayed by devices that are physically within the geofence of like Times Square, New York City, or in the geofence of the historic district in Mexico City, right? So clearly, all these attributes or fields of data by which we can grant or restrict access are going to vary greatly by the type of asset, the type of distribution. And it is here where we see that M&E companies recognize that traditional database systems and their inherent rigidness, right, inhibit sort of the agility needed to keep up not just with the variety of data, but also with the volume and velocity. And that leads us to like the three V's of data: variety, volume, and velocity. And so, for example, we are working with like major film entertainment companies here in Los Angeles that manages a highly, and I quote again, highly tuned relational database cluster that has over 1 billion records for their DRM data store. But they recognize that the data in that large cluster is not pure DRM data, but it's also kind of the associated entries in the database that are required to keep the data model together. And as they're trying to fit this is highly dynamic and highly malleable kind of data entities, which is again is the right to access, into a rigid model, they now realize that they need to modernize their data platform. So rights management is just one example of those use cases that are present at media companies that do require sort of modernizing their data platforms by moving to the cloud, right, where they can now modernize their data. They can query and search across unstructured or semi-structured data and expand across cloud regions so they can serve their customers now anywhere they are with the lowest latency possible, right? Or even expand across cloud providers and provide the highest reliability on a global, on a growing global audience. Sorry, and that's where MongoDB Atlas, right? And we'll talk about that more later, can really help them by being cloud agnostic and being able to deploy it across any region in any of the supported cloud providers. So, kind of speaking of that global audience, right, and the need to create more content faster, Lisa, how can studios work more efficiently to avoid that kind of the recreation of existing assets and be able to produce content more rapidly and keep up with the viewer demands?
It's a great question, and it kind of goes back to the whole idea of garbage in, garbage out, and having the right information associated with your files. What we have seen here with one of our major studio clients, they had a stock footage library, which is great, except that they could never find what they were looking for within that stock footage library. And what they found is that every time they went out into the field to record the B-roll or the stock footage that they needed, they were spending thousands upon thousands of dollars just to get that stock footage. And so what they were able to do is to take that archival content, get it into the system, get it cataloged, get it findable, right? So again, you need to have the right metadata, but you'll also need to have the right index, and you need to have the right terms to be able to associate with things. And so by moving their stock footage library online and having the proper information around it, Fox was able to more easily find the content, therefore be able to reuse that content, and therefore get to market faster with some of their productions that they needed to do. So it really, it increased cost savings, one, because they weren't sending people out to produce the video themselves, but also they were accelerating their production schedules because they already had the content at hand and could incorporate it into the editing and creation process sooner.
Perfect, perfect.
And so,
go ahead.
As we know, the content can go viral a minute, right? I mean, all you need to do is to get something onto social media and things explode. So Sig, can you tell us more about what media news companies are doing to catch the momentum and drive more viewership when you create that tiny window of opportunity?
Yeah, certainly. So we talked about the 3 V's of data before, again, volume, velocity, and variety. And I feel like we should focus a little more on volume and velocity in particular. So when content goes viral, media companies are now finding that they need to not only be able to serve that content at scale across the world, but also capture the viewer interactions and be able to aggregate data in as real time as possible, covering potentially millions of views for an article or an asset, and perhaps tens of thousands or even hundreds of thousands of comments, and be able to obtain immediate insight into how the readers are responding to the content. So to then serve even more content and continue to capture the viewer's attention, right? Essentially, the more you interact with their platforms and share and browse, the more content can be tailored and served to you again, right? To continue capturing that attention. Now, hopefully not everyone is walking down at their phones like in the picture here, but I think that's obviously some of the ways that media companies are certainly monetizing some of the content, right? And so what we're seeing in the field is a move to platforms that let them simplify the capture and analysis of this data. And you can think of it as a click stream, right? What people are looking at, what parts of the page they're viewing, what they're sharing in their social networks, and so on. And so media companies now need a data platform that can handle all of this data in its varying forms. And that's why I talked about volume and velocity, right? So they can then be ingested easily across cloud regions or even across cloud providers. For example, Forbes, and we'll actually hear more about their use case later on, decided to overhaul their content management system on our cloud data platform, and now it's incredibly fast, right? It's open to contributors that are global. They can change without going offline, and more importantly, it handles those millions of article views per day, and all at a fraction of the time and the cost, of their old approach. So, speaking of the millions of articles and the 3 V's of data, variety, volume, velocity, I think we should turn it over to Thierry Del Prat, CTO of Nuxeo, on an exceptional benchmark that was recently done. Thierry, over to you.
Hi, thank you. Hi, everyone. So my goal in here will be to give you a brief overview of the benchmark we did last year, where we actually reached 11 billion documents. This is a benchmark we did in partnership with MongoDB. So my goal will be to present you how we use MongoDB, the result we get. So it will be just an overview, but to be completely transparent, you should have all information in the link below. Usually we do everything the open source way, which means you should have access to everything we did during the test, including the source code, the test scenario, and so on. Actually, I did most of the work during the lockdown, so I spent a few weeks in a small Brooklyn apartment with 11 billion documents, so I had some time to actually write down results and explanations. So why was this benchmark slightly different than what we used to do before? The first aspect is that clearly we wanted this benchmark to be useful. We wanted to be able to extract actionable knowledge. so that we can give that knowledge to our customer and to the people running Nuxeo Cloud. So the first aspect is that we didn't go directly to 11 billion. We actually did several steps, starting importing document, then testing the result, scaling the infrastructure until we get the correct performance result, then take a snapshot of this so that we have a blueprint we can give to customer and to ops people, and then move to the next step. So we went from 0 document to 11 billion, step by step. The other aspect is that it's quite easy to do a test in a lab where you take a lot of shortcuts, but actually when you try that in production, it's slightly different because you have encryption enabled, because you have the backups running, because the security is not the same, because you have the various scanner running and so on. So we did the test in an actual production environment with all the same setting as the one we use in our Nuxeo Cloud environment, which means deploy everything on AWS and rely on MongoDB Atlas for the data tier with everything activated in terms of security, backup, and so on. And the last aspect is that it's actually not that interesting to test just a storage layer. What we want to test is an actual application with actual use cases so that we can validate that it works for real in a real use case. So for that, we spent some time with different customers. So I'm sorry to say that for this specific benchmark, the customer that came up with the most interesting use cases in terms of very high volume were more on the banking side. So that's why we actually, if we can go to the next slide, please. We actually build a dedicated Nuxeo application with a specific content model to be able to store the different kind of data inside the bank system. So typically something to represent the customer, something for the account, statement, and so on. So we build all that with a dedicated UI, configuring everything so that full text indexing is actually done, and we have thumbnail for everything. And we can have a real application that we can test. And the idea was, okay, we do it step by step. We load real data with different files, different metadata, meaningful text inside the application. Then we do a complete testing using a meaningful scenario in terms of navigation, search, update, bulk update, and so on. And then we repeat until we reach 11 billions. So, yeah. Thank you. So actually, when you are doing this kind of benchmark, the goal is to find what will be the bottleneck, what will be the challenges. So we know that with MongoDB, we don't have any problem in terms of being able to store arbitrarily complex content or very deep hierarchy because it works perfectly. We also know that in terms of read, MongoDB is never the bottleneck, but clearly when you want to ingest 11 billion documents, you can foresee that basically the I/O part will be the limiting factor when you need to import this 11 billion document. So obviously the first bottleneck was to be able to generate 11 billion files that are completely different with meaningful text. But once done, the question was how can we inject that inside MongoDB as quickly as possible? And going through all the application layer for that. Luckily enough, there are a lot of options inside MongoDB Atlas, and we leverage that to maximize the available I/O, typically using NVMe drives so that the I/O is much better. Being able to scale up the MongoDB instance to have more memory available and being able to accelerate the way the index are managed, and then being able to scale out to spread the load between different databases. At the same time, just scaling up and out indefinitely is definitely not cost efficient because resources have a cost. So we were able to adjust using the capabilities provided by MongoDB Atlas. We were actually able to properly tailor the kind of storage and the size of instance so that we have something that makes sense and is cost efficient, and we can actually scale up or scale down depending on what we actually need inside the application. So the way we organize that, and if we can go to the next slide, Sig, please. So at the end, we had 11 billion documents. And after discussing with the customer, it became clear that actually most people don't have 11 billion documents that are all live, where everyone needs to update them on a regular basis. So we ended up with this approach saying, okay, we will put on one side the live document, the one that are recent, where people are still working on it. And then on another side, we'll put the archive document. So because the use case was a US bank, we split the customer and the account in two parts, one east, one west, and then put all the archive in a separated database, which allow us to actually use different kind of storage. So if you go to the next slide, actually for the two live repository, we use NVMe based instance so that we can import as quickly as possible, and we can have very good response time when it's doing bulk update and so on. And then for the archive part, we use a sharded cluster to be able to spread the right capability. But obviously, we were also able to scale up during the import phase and then scale down when just testing the search and the usage of the application. All of this being indexed in one big Elasticsearch index, so that from the user standpoint, everything looks like a single application, because actually it's a single application. Then if we can move to the next slide. Obviously you will get, if you're interested, you will get much more detailed result in the link that should be below. But I guess the takeaway is that even with 11 billion millions of documents stored inside the repository, we can still have very good response time, meaning you can navigate the application, the response time are good. You can search even with full text and complex faceted search. It works well. At this point, you can still import documents. So here you have an example of throughput. We can still import at more than 25,000 documents per second, which means that you import more than 1 million documents in 1 minute, which is usually enough for most of the use cases. And one aspect that was part of the feedback of the customer when we actually build the testing scenario was, okay, can we still do a full reindex? For example, we change something in the configuration and we want to reindex all the repository. Then it doesn't work if we need 3 weeks to index all the repository. So that's why we also did pure bulk indexing test. And we see that we reach more than 50,000 documents per second, which means we can reindex a big part of the repository in just 14 hours. So that's the main takeaway, is that it works. Obviously, you will get much more result in the link below.
And maybe to mention too, right, Thierry, is that these are rich data documents. We're not talking about sort of a flat row, but these are rich structures versus if you're using a traditional database. There would be probably more rows, but it would take more time because you're essentially ingesting that data sort of flattened out and normalized, right? But in here, we're dealing with this kind of this rich data, right?
Yeah, and to be clear, it's a real application where everything was configured with, as I said earlier, a user object, then you have account. For all of them, you have potentially complex metadata that are basically nested metadata. So as Steve is saying, it's not just one row with an ID and a name. It's much more than that. It's an actual content, it's a complete content model with all the right data, so that it's actually meaningful, because otherwise when you do search or faceted search, you don't have any data to search on, or everything ends up in the same bucket. So here we wanted this to be realistic so that we can extract actionable result. So that's why we tested with real data, and we spent so much time also on how do we generate 11 billion data that makes sense, that is not always the same, and at the same time will actually make sense in terms of full text indexing, because if you don't do it correctly, you quickly have a side effect that makes the results are not really meaningful.
Yeah, absolutely. Outstanding.
And obviously, we did that from 0 to 11 billion document, and we were able to progressively scale the infrastructure. So it's true on the Nuxeo side, but it's also true on the MongoDB side. And Here, the very interesting part when using something like MongoDB Atlas, so a PaaS service that does pretty much all the heavy lifting for us, is that we were able to adjust the size of the infrastructure when adding content. So we didn't have to say from day one, we need a big cluster. We started with a small cluster, then we scaled up the cluster, then we added a second cluster, then we used sharding. We did it step by step, and even better, we were able to allocate the big cluster that was needed to be able to run, for example, the archive repository with 9 billion documents, but we actually over-provision it using a M80 kind of cluster, just to be sure I didn't have to wait several days for the import to be finished. And then we scale it down to a M40, which is much, much smaller, but still perfectly able to actually handle the needed load in terms of navigating and using the content. It's just slower for the import part. So it gives us this cost efficiency, and the fact that we can do that without having complex operation is basically just going on the MongoDB Atlas console and clicking on a few buttons, and then automatically everything is migrated and resized. So it's very comfortable, and it allows to be cost efficient and scale the platform progressively.
Yes, and maybe for the audience, not everyone might be familiar exactly with the way Atlas works or what this M40, M60, M80 mean. Atlas has sort of its own t-shirt sizing, or we call them cluster tiers, right? And M40 is X amount of CPU, X amount of RAM with a X amount of disk and IOPS that you can obviously increase. But the beauty of Atlas is that these cluster tiers are relatively the same horsepower or hardware, whether it's an AWS, an Azure, and Google Cloud, etc. And like you mentioned, Thierry, right? You're able to scale from an M40 to an M60 to an M80, or even down again seamlessly, right? It's through the click of a UI or through a REST API or a Terraform change in your configuration, right? Without downtime, right? And without a team of operations engineers, right?
I mean, the team was basically me, and I'm definitely not an ops guy. So I literally just had to click a few buttons and then wait. And we even ran tests during the resizing, just to verify that you can actually do that in production without having any glitch or availability issue. So indeed, we run full test and ingestion while resizing one of the MongoDB Atlas cluster. And the test ran perfectly without any issue.
That's perfect. That's awesome to hear. Amazing. Alrighty. So we move on?
Yeah, perfect. Okay. So I guess we did this test using MongoDB Atlas. Actually, it was not just because they were a partner. This is also because this is the solution we actually advise everyone to use, and the solution we use in our cloud. So my goal here is just to give you a few explanations about why MongoDB works well for our use case and why we recommend to use MongoDB to our customers. So from a very high-level standpoint, just a few explanations about how Nuxeo works. So at the heart of the Nuxeo platform, we have the content services, let's say the repository, where we store the document. But actually, we don't only store documents, we also usually store users. We have the audit logs for the different events that can occur on the document. We also need to store transient result, typically asynchronous process result. And all of that, we have dedicated storage services with the idea that we can change the implementation of each of the storage and find, depending on the different use cases and the different infrastructure, what is the best storage for each kind of data. And it just happened that we ended up doing a MongoDB backend for each of these storage, just because it works super well. And it basically allows to have one MongoDB database where we store the different kind of data in different collections. We even have a backend that allows to store the blob themselves inside MongoDB using GridFS. So that's just to give you an overview of how the system works. So why does it work so well between Nuxeo and MongoDB? What are the gain we have from using MongoDB? And I guess we can move to the next slide. The first aspect is that we obviously also have historically a SQL backend. And with the SQL backend, you need at some point to do the mapping between your complex data object and a set of tables and rows. And this additional layer is additional code. So more code is an impact in terms of performance. Usually you need to add some caching, which is always making the management a little bit more complex. And the more code you have, the more maintenance and possibility of issues you have. So in the case of MongoDB, because we can directly store a JSON document, we can just take the Nuxeo document object and transfer it in JSON directly to MongoDB. So it means we have no impedance issue. We don't have the mapping between one document and n tables or rows. So as a result, it gives also a much better write throughput. Just because the locking system works differently, we don't have the issue that we have usually with databases, where because we store complex documents, we need to write in multiple tables on multiple rows. When you do that, you have a lock escalation that makes that at some point you are reaching the maximum possibility. And the last aspect that we directly gain from MongoDB is the fact that, okay, we actually can do scale out. We can rely on the fact that the database allows sharding and that we can spread the write load on multiple instances. So that's very efficient for us. I figure it was making sense to kind of put in parallel MongoDB and Nuxeo, just because on some aspects they are very similar and some aspects we are very complementary. So on the scalability, on the Nuxeo side, we have the ability to do auto-scaling for everything that is tied to processing. So we just allocate a bunch of nodes and scale the number of nodes dynamically depending on the workload. And then on the MongoDB side, especially when using something like the Atlas service, we can do transparently either scale up or scale out at the data tier level. So it means we can scale both at the processing and at the data level, which gives us the maximum number of options for being able to handle scalability.
And maybe good to also mention that we can also scale the reads and the analytics by also adding more data replicas, again, across cloud regions within cloud providers. So you can always scale up in terms of the physical hardware, or you can scale out by adding more shards, but you can also sometimes scale by simply adding more read replicas if you just need to kind of replicate content in various parts of the world, right?
Right. And we also have similar, well, let's say complementary approaches to sharding. At the Nuxeo level, so I would say at the application level, we can have more than one repository. So that's why we call application level sharding, with the idea that we can actually split data in different repositories so that we can use different backend or different size of MongoDB cluster. That's typically what we did during the benchmark. And at the MongoDB level, we can do data level sharding, which is completely transparent. We just define that at the replica set level. And then we can leverage the fact that we can spread the write on multiple nodes. And here again, that's exactly what we did during the benchmark. We used both the application level sharding and then the data level sharding inside MongoDB in order to be able to achieve the 11 billions repository.
Yeah, I love that. I mean, it's great that databases provide that horizontal scalability and that partitioning, but that's also just one way of addressing large scale, right? So I think a combination of both application level sharding and database level sharding is what's going to provide, the best future proofing, right, for any platform. And it's amazing that yourself, obviously CTO of Nuxeo, you realize that there's things the database can do, and there's things that you can do at the platform/application level, right? And I think that the proof is in the pudding, right? The fact that you're able to achieve this test, exactly doing that, right? Different clusters for different purposes.
And that's definitely good to have this flexibility. And the last point I wanted to mention is the fact that at the Nuxeo level, we are usually exposing the API so that our application is basically the source of truth for all content, so that you can store the document, the user, the record, everything is actually managed by Nuxeo and expose an API, and all other applications can actually use this content service to read and write content and getting the most up-to-date information. And the fact that we can use MongoDB for all the different backend, being it the audit, the document, the key value store, and so on, makes that we can actually consider that MongoDB is our unique source of truth, which makes it much easier in terms of backup management, transaction management, rollback, and so on. So it's very good. And if we add on top of that the fact that we can transparently scale both Nuxeo and the storage, it's actually a very nice combination that gives us a lot of flexibility.
And we're definitely hearing a lot in the field, and especially in media, entertainment, and gaming, that the combination of Nuxeo and Atlas is certainly gaining traction. That's good to hear. And actually, speaking of gaining traction and kind of what our customers are doing, why don't we talk a little bit now about our shared customers and sort of their journey towards how they're modernizing their digital assets. So let me start with Forbes, which I think we talked briefly earlier on. And by the way, thanks, Thierry. That was a really great insight into the Nuxeo platform, right? In the 11 billion benchmark test, by the way. So with Forbes, I think Forbes has been a leading source of business news, since 1917, and they always produce quality content, right? But what they were lacking a few years ago was speed. And they couldn't keep up with the quickening pace of journalism. They had old closed systems, they had outages, so they knew that any architecture changes were going to be costly and require a lot of time. So they realized that it was kind of time for a complete do-over. So they set out to actually rebuild their entire content management system on MongoDB. And this took them about 2 months, which is actually quite surprising. But that proves sort of the agility that you can obtain, once you start with MongoDB, especially if you're building from scratch, right? And so after they built the CMS, then using just literally one full-time engineer, they then launched a brand new kind of mobile site or mobile experience that was obviously powered by the new CMS in also less than a month. And so now, because Forbes was leveraging the MongoDB's JSON document model, just like Nuxeo is, they were able to continuously now sort of evolve their sites and to scale across the geographies so they could accommodate distributed writers or contributors, and also leverage some of the capabilities that come with MongoDB for analysis of what the readers or the viewers were doing. But more importantly, right, the new CMS allowed the content team to be distributed, which I believe they have over 2,800 journalists today worldwide, and they're able to handle that viewer clickstream at scale. And as a result, they've actually increased, their mobile traffic now. It used to be 5%, so most people will obviously, read either the website or magazine. Now their mobile traffic is increased from 5% to 60% on the mobile, and because of that, they can now analyze the reader behavior as it happens and line up essentially the next best content in front of the readers within seconds, right? So today they actually have over 78 million monthly visitors in the US that are creating over 50 million social touch points. So, truly a modernization story that they went from, kind of old closed systems to modern mobile serve content anywhere. So let me pass it over to Lisa and hear about what Fox Television Studios is doing.
Great, thank you. I've got to say that Forbes use case is pretty impressive to be able to increase traffic so much. It's pretty amazing. earlier we talked about kind of the stock library, the video stock library use case, and that was particularly for Fox television studios. And so as we talked about from a roadblock perspective, they were unable to easily locate any of the previously filmed stock footage. Again, talk about another company that had nearly 100 years of content available to them in one way, shape, or form. And they had it, but they couldn't use it. And so what they were able to do is to create the stock footage library to be able to take advantage of reusability. And so within that, they saved time. They eliminated the need for reshoots that they were having to do. One, that's a cost savings, but two, that also reduced the production schedules and made their production schedules more predictable. Because they were able to say precisely what they needed to shoot versus relying on somebody being able to locate the content. And so the benefits in terms of using Nuxeo with Mongo is that we were able to put together some federated search and find capabilities. Again, that's the very important part, is being able to find the content that you're using, and also overlay that with some relatively complex content itself. You know, this is video footage. This is not necessarily your very stock structured data. So we had the benefit of federated search and find with the video. And ultimately, the impact was that they were able to save hundreds of thousands of dollars every month on the buy-ins that they needed to do for being able to license other content that they were needing to create. And again, they were also able to have more predictable production schedules and budgets.
Amazing, amazing. And finally, I think our next shared customer, we actually cannot name them, but you can probably tell who they are after we talk about them. But Lisa, tell us a little more about what sort of the roadblocks that this major household film production company was.
Sure, and I think I'll only have to make it through the first line or two, and we'll be able to tell what it is. But they have superheroes that have been around for decades, and there are very many different iterations of these superheroes, and they had different designs and different licenses associated with the various designs, and so they needed to be able to track not only what design was what, but what usage they had behind that. They had multiple homegrown systems to kind of put this in. This is a company that in essence has grown over acquisition. And so being able to kind of connect and integrate all of these various systems. And so they had challenges around data synchronizations. You know, with different systems come different tools to be able to describe them and different vocabularies that may be used. So they had problems with the sync on the data as well as deduplication. Ultimately, when you have years and years and decades of content, you want to make sure that you are not doubling up, because even though storage is cheap, storage over time can be quite expensive. And so we also needed to make sure that we had tight IP and security restrictions under control. Imagine that the latest blockbuster gets out, or anything related to that latest blockbuster, any of the licensed paraphernalia, you know, any of those, the figurines get out ahead of time. You have potentially lost quite a bit of your revenue before that. So we wanted to make sure, and we need to make sure, that the data that we have is secure.
Yeah, absolutely. And in terms of like time savings, right, I think we should also highlight that with only 2 DAM librarians, this film production company was able to serve the network of over 2,500 licensors, and again, speed up the licensing, review and approval process substantially. And of course, you know, it was luckily done in time just before, you know, the pandemic of last year. And so today that everything is done online, right? No more going into the studios or the offices to submit designs and so on. Everything is remote, and they're able to now actually expedite now their licensing approvals, which is really helping with revenue.
Oh, absolutely. It helps in revenue, and it allows the company to be able to respond quickly to trends within the market as well. So absolutely, being able to pivot quickly is something that's useful. And in the way they were able to allow just these 2 librarians to handle over 2,500 vendors and licensors kind of comes down to that integration and the benefit that we see by using Nuxeo on top of that single source of truth of the Mongo database. So, it allows us to search for those 350,000 assets, to be able to actually pull them out and to gain even more revenue from existing things, and really take advantage of the creative process and not just the completed work.
Well, I think we took help them to get to 11 billion assets,
exactly.
like the way theory did.
Exactly.
So again, I think the impact is obviously being felt, at this major company. They're able to launch movies in theaters where possible, and also in the streaming service. The revenue has increased, and that they have faster time to market because of licensed products, and they actually launch in parallel, right, with movie and show campaigns. And essentially, when either some of the movies actually got delayed because of the event, but now all of the licensing, action figurines, T-shirts, etc., is ready to roll out into the market as soon as the movies are able to release or now to be broadcasted in their own service. So great. So that actually does brings us to the end of our webinar. Wanted to obviously thank Thierry and Lisa. This has been a great conversation. I love what things are going on, in the media entertainment space. Maybe next time we do something around gaming or something around more like architecture patterns, like Thierry was showing us, apply to media entertainment. But I want to open it up to the audience, see if there's any Q&A, anything we can, that's top of mind for anyone.